Homework 3.5, Rational Functions, Video 10. Homework due Wednesday, May 27, 2020 at 11:59 p.m. This video, as the previous two and the next one, correlate to questions 17 through 21 in the homework. So let's do a third example. And this is one we actually saw earlier, and I said we would graph f of x equals x squared over x squared plus 4. Let's start with symmetry. To check symmetry, we need to check even or odd, which means we need to start by changing each x to a negative x. Well, both of the x's are squared, so the square will kill the negatives on both. I'm going to go ahead and write negative x squared and negative x squared plus 4 on the bottom, just to show that I actually inserted them. But the square kills both negatives, so we end up with x squared on top and x squared plus 4 on the bottom, which is precisely the original function. Putting in a negative is the same as putting in a positive. That's the definition of an even function, and an even function has y-axis symmetry. So whatever we get on the right, we can take the mirror image and get on the left, or vice versa. What's the y-intercept? Well, not to sound like a broken record, but all of these, until the next one, seem to have the same intercepts, but don't assume that will always be the case. For the y-intercept, put in 0, we're going to get out 0. For the x-intercept, put it equal to 0, solve the top, and we're still going to get 0. So I'm kind of disappointed that all the examples I set up have the same x and y intercepts, but to be fair, these all came out of the homework, so you should expect the same, but don't just assume it. Vertical asymptotes. This is the one where we put the bottom equal to 0, we got x equals plus or minus 2i, which aren't even real numbers, which means that there were no vertical asymptotes. So we already played that game in a previous video. Well, what about the horizontal asymptote? Check the degrees. Who has the greater degree? They're the same, x squared and x squared. So the horizontal asymptote is y equals the ratio of leading coefficients, 1 over 1 is 1. So it didn't take us long to analyze that. Vertical asymptotes probably would have taken the most amount of time had we not calculated them earlier. Let's sketch what we have. We know that there's an intercept at the origin, it's the only one. There are no vertical asymptotes, but we have a horizontal asymptote at y equals 1. Now, if you're wondering why I'm not putting 1 so far up, because I kind of already know what this graph is going to look like. Well, this isn't much to go on. Here's what I know. The ends have to get close to the horizontal asymptote. It's got to touch this, and that's the only intercept. Can you get an image of what this is going to look like? Maybe, maybe not. Let's go find more evidence. Now this time I'm going to put in positive numbers first. So let's pick some positive numbers. Let's just go 1, 2, 3. There's no need to get crazy here. 2, 3. And we'll also do -1, -2, and -3. But I really only have to put in three of those because I know that an even function, opposite inputs produce equal outputs. So whatever I get for 3, 2, and 1 is the same outputs for -1, -2, and -3. If I put in 3, I'll get 3 squared, which is 9 on top, and then 9 plus 4, which is 13 on the bottom. I'll turn that to a decimal in a minute. I don't know 9/13 off the top of my head. If I put in 2, I get 2 squared on the top, which is 4, and at the bottom, add 4 more to get 8. Well, 4 divided by 8 is exactly 0.5. And if I put in 1, 1 squared is 1, and then 1 plus 4 is 5, 1/5 is 0.2. Let me figure out 9/13 real quick. I got a whole cache of calculators here. They kind of collect. 9 divided by 13 to a couple of decimal places, it rounds to about 0.7. I mean, I'm not going to subdivide this into hundreds, so there's no need for 2 decimal places, but it rounds to about 0.7. Okay. Oh, wait a minute, the negatives, but I don't have to do them. An even function means that opposite inputs give equal outputs. So -1 gives the same answer as +1, 0.2. Negative 2 gives the same answer as positive 2.5, and negative 3 gives the same answer as positive 3.7. Now, because these outputs are so small, I think it's a good idea to subdivide this at least into quarters, 0.25, 0.50, 0.75, so I can kind of gauge where to put these values. All right, let's plot 3, 0.7, so 3 and not quite this high. Let's plot 2, 0.5, that's easy. And let's plot 1, 0.2, that's about here. I wish I hadn't drawn this so wide, you'll see why in a minute. And then these guys have the same output, so I just have to do this. Well, that makes sense, it has y-axis symmetry. So can you kind of see the graph? I wish I had room to put bigger values in, like 4 and 5. If I put in 5, I would get 25 over 29. That's close to 1. If I put in 10, I get 100 over 104. That's really close to 1. So it almost looks like an upside down bell curve. Remember, there were no vertical asymptotes. So let's see how close I was. You have disconnected your phone from your computer. I have to keep it plugged up to keep a charge on it while I'm filming all these videos. All right, so we had x squared on the top. So x to the second. And on the bottom we had x squared plus 4. Oh, it looks so sad or scary. The graph looks like a scream face. Oh yeah, it's a vertical line. It's a horizontal line. It's f of x equals 1 at this point. Let's turn all this off. Okay. Oh wait, I gotta put the plus 4 down here. Plus 4. Let's zoom in on that. And let's put the y equals 1, which we said was the horizontal asymptote. There it is. I think I've told y'all in the very first series of videos that I know a lot of what I'm going to show you is not going to be applied in whatever career you choose, unless you choose a very science or mathematical oriented career. But you got to admit that being able to analyze that function, do all this analysis and sketch by hand this graph, and then having technology confirm that we're correct is a pretty good feeling. Plus remember, the math way predates the technology. The technology just makes it easier to get the answers, but it doesn't really explain the analysis. Got one more example for you. It'll have a hole in the graph.